Hello students, these are the topic tests on quant by Bodhi Prep. So once you've completed the basic concept of a topic, you can take this test and see whether you're able to solve those questions or use those concepts in a test mode. Once you've attempted the test, that is when you go through this video. This video gives you the solution for the questions and also brief analysis of what the test was like, what should have been a good attempt, and the kind of time that you could invest in the test. There are more than 200 such topic tests available on the Bodhi Prep Android app. The link for the app is in the description below. So download this app and make the most of these tests. This video is on the topic quadratic equations, and this is the test number 4 on this topic. Overall, this test was a moderate level of difficulty with about 6 questions correct, giving you a 95 plus percentile. The ideal time to go through the test should have been about 25 minutes, where we may not solve all the questions, but we'll get our 6 questions net correct. If you look at the questions, the first question says, what is the value of root of 3 plus root of 3 plus root of 3? Now, we can see that from this point onwards, the pattern is repeating. So there is a root of 3 plus, from this point it repeats. So if I say x is equal to root of 3 plus root of 3 plus root of 3 and so on, from the first point of repetition, we can replace that by x. So we can write x is equal to root of 3 plus x. From here also this will be x because it extends up to infinity. Now taking the square, x square is equal to 3 plus x gives us x square minus x minus 3 is equal to 0. Therefore, the value of x will be minus b, so 1, because b here is minus 1, plus minus root of b square 1 minus 4ac upon 2. So this becomes 1 plus root 4 to the 12. This will become positive root 13 upon 2 or 1 minus root 13 upon 2. Now clearly the root of 3 will be a number which is positive. This value will be negative, so this is eliminated, and therefore the value of x becomes root of 13 plus 1 upon 2, and that becomes our answer, option A. Now clearly this I would say is a question which would be easy because it's a standard question and the repetition is happening at one step. So all we have to do is square and solve for quadratic. Should not take about more than 2 minutes to solve. The value for which one root of the quadratic equation, this is the equation, a square minus 5a plus 3 into x square plus 3a minus 1 into x plus 2 is 0. One root is twice as large as the other root. So if one of the roots is alpha, the other root is twice as large, therefore 2 alpha. Now sum of roots, that is alpha plus 2 alpha, can be written as minus b by a. So minus 3a minus 1 in the bracket upon a square plus 5, a square minus 5a. Minus 5a plus 3. So 3 alpha will be minus 3 minus 1 upon a square minus 5a plus 3. And the product of roots alpha into 2 alpha will be c by a. So 2 upon a square minus 5a plus 3. Therefore 2 alpha square, or we can cancel out 2 and 2. So alpha square will be 1 upon a square minus 5a plus 3. This is alpha squared. If we square this, the first equation, we'll get 9 alpha squared is equal to, minus becomes plus, so 3a minus 1 whole squared upon a square minus 5a plus 3 whole squared. Alpha square can be replaced, so we get 9 upon a square. This is 9 upon a square minus 5a plus 3 is equal to 3a minus 1 whole squared upon a square minus 5a plus 3 whole squared. So this entire thing gets cancelled from here. We just have to ensure that this was not 0. So the condition that we are taking, a square minus 5a plus 3 is not equal to 0 in the condition that we are taking. Once we get the answer, we'll check for this. Cross multiplying 9a square minus 45a plus 9 3s are 27 is equal to squaring this 9a square minus 2 3s are 6. 6a plus 1. 9a square cancel. So we get 27 plus 1. 28 is equal to, or rather 27 minus 1. 26 is equal to 45 minus 36. 39a. Therefore, a is equal to 26 by 39, which comes out to 2 by 3 divided by 13. The value of a from the options is 2 by 3. We'll just check the value here as well. Since there is none of these options, this has to be the answer. But just put the value of 2 by 3 here and check whether this becomes 0 or not. So a square 2 by 3 becomes 4 by 9 minus 10 by 3 plus 3. This is nothing but 4 by 9 minus 30 by 9 plus 27 by 9, which will be 31 minus 31 by 9. So this is not equal to 0, therefore acceptable solution, hence 2 by 3. Since the options do not have none of these, we don't have to check for the last step, but just in case. I'll say this is a moderate level of question because there is some sort of substituting values that has to be done, and therefore the level of difficulty increases. About 2.5 minutes, 2 to 2.5 minutes to solve this question, because at the end of the day, we don't have to solve for a quadratic since the a square term got cancelled out any case. So the calculation will not be that difficult. If the roots of the equation x square minus bx plus c is equal to 0, two consecutive integers, let the roots be 1 and 2 consecutive integers, and therefore we can say the equation will be x minus 1 into x minus 2 is equal to 0, which means x square minus 3x plus 2 is equal to 0. We have to find the value of b square minus 4ac. b square minus 4ac will be 3 square minus 4 into 2, which will be 9 minus 8, hence, sorry, not 0. We are finding the value of b square minus 4ac. So 9 minus 8 is equal to 1. Option A becomes the answer. Simple, easy question. Just put the values and solve. And that is good enough for an answer because options, we have integral values. So it has to be true for any set of values. Therefore, easy, not more than a minute and a half to solve it. If we want to actually solve the question, we will take the roots as, say, p and p plus 1. Therefore, we'll write sum of roots, that is 2p plus 1 is equal to b by 1, and product of roots, that is p into p plus 1 will be equal to c, product of roots. B square minus 4ac will be 2p plus 1 whole square minus 4 into p plus 1. This becomes 4p squared plus 2p into 1 into 2, therefore 4p plus 1 minus 4p square minus 4p. 4p square, 4p cancel, and therefore 1 is left. So that is the answer. Whether you take variables or the number, both cases, it is not very difficult. But I think it is easier by assuming numbers and then directly solving. In any case, not more than a minute and a half to solve this question. Difference between the corresponding roots of x square plus ax plus b and x square plus bx plus a is equal to 0 is same. Then if we take the roots of this to be, say, p and q, and here r and s, difference between, so it is given that p minus q is equal to r minus s. Squaring will get p minus q whole square is equal to r minus s whole square. And this is nothing but p square plus q square minus 2pq. R square plus s square minus 2rs. P square plus q square can be written as p plus q whole square minus 2pq. This will become minus 4pq. Similarly, r plus s whole square minus 4rs. P plus q from this equation will be minus a, so a square. Pq will be b minus b. A square minus b is equal to, from here we'll have r plus s will be minus b whole square minus 4rs will be equal to product of roots minus 4a. So this means a square minus b square will be equal to 4b minus 4a. This is written as a plus b into a minus b. This is minus 4 into a minus b. A is not equal to b is given in the question, so we can cancel out a minus b from both sides. Therefore, a plus b is equal to minus 4, which means a plus b plus 4 is equal to 0. So if the difference of roots is same, then a plus b plus 4 should be equal to 0 according to the question. A becomes the answer. Again, it's about squaring and then solving. So the first step might be or getting from here to here might be an issue. Once that happens, the question will follow from there. I'd say moderate level of difficulty, about 2 to 2.5 minutes to solve the question. The quadratic equations x square minus 6x plus a is equal to 0 and x square minus 6cx plus 6 is equal to 0 have one root in common. Suppose that root is p. The other roots of the first and the second equations are integers in the ratio 4 is to 3. Suppose the other roots are 4q and 3q. Therefore, x square minus 6x plus a is equal to 0 has roots p and 4q, whereas x square minus cx plus 6 is equal to 0 has roots p and 3q. We have to find the value of p. We have to find the value of p. From here we can write p plus 4q is equal to sum of roots, so minus b by a, which becomes 6. And from here we can write p into 3q is equal to c by a, which is 6. Therefore, p into q is equal to 2. We have to find the value of the common root p. So q is equal to 2 by p. If we substitute that value here, we get p plus 8 by p is equal to 6, which means p square multiplying throughout by p plus 8 is equal to 6p, which means p square minus 6p plus 8 is equal to 0. Sum of two numbers is 6, product is 8. So p minus 4 into p minus 2 is equal to 0. So p is either equal to 4 or p is equal to 2. We have to find the common root. So we have to eliminate one of the solutions. Now, if we look at the two solutions, if p is 4, q would be 2 by 4, which is 1 by 2. And therefore, the roots will be p and 4q, or 4 and 4q, which is 4 and 2. So this is okay. 4 and 3q. This will be 4 and 3 by 2. We know that the other roots of the first and second equation are integers. This is not an integer. If we take p is equal to 2, q will be equal to 2 by 2, which is 1. And therefore, the other roots will be 4q and 3q, which are 4 and 3. So the roots become 2 and 4 and 2 and 3. Since integral roots happen at p is equal to 2, therefore we eliminate this solution, and therefore the required solution for us is option A. I would call this question a moderate level of difficulty because there is a switch that has to be made from P to Q, eliminating Q, and it is very easy to get confused with A's and C's. Also, in the end, eliminating 4 could become tricky because the simple statement of integers or the word integers might get missed. So, moderate level of difficulty, and the solving time also about 2.5 minutes for this question. Ax plus b plus 3 by ax plus b is equal to 2. We have to find the value of ax plus b whole cube minus ax plus b. The first step I'm doing is I'm putting ax plus b equal to y. Because if we solve for y here, we can simply substitute the value. Therefore, y plus 3 by y. Doing this so that ax, b, 3 variables are eliminated and I just work with one variable. So y square multiplying by y throughout, y square plus 3 is equal to 2y. Which means y square minus 2y plus 3 is equal to 0. Now this will give us b square 8 minus 4 is 12. This will have no real roots. We have to find the value of y cube minus y, which is nothing but y into y square minus 1. From here, if we try to find the value of y square minus 1, so I'm eliminating the step, we can write y square is equal to 2y plus 3 or 2y minus 3, and therefore y square minus 1 will be equal to subtracting 1 from both sides, 2y minus 4. So this becomes y into 2y minus 4 y into 2y minus 4, which is 2y into y minus 2. 2y into y minus 2. Can we find y minus 2? Y minus 2. From here, the first step we can write y plus 3 by y is equal to 2. So y minus 2 will be minus 3y. Interchanging the sides of these two terms. So instead of y minus 2, we can write minus 3 by y. So this gives us 2 into y into minus 3 upon y. Y and y cancel. The value here comes out to minus 6. Option B becomes the answer. I would call it a moderate level of difficulty question because if you're dealing with ax plus b, the arrangement becomes a little difficult, I think. Also, the solution for the quadratic y square minus 2y plus 3, we do not get real roots, and therefore, if we work with this, it will be difficult. But if proper rearrangements are done, then the question can be solved in about, the question can be solved in about 2 to 2.5 minutes. But in any case, definitely a moderate level of question, if not higher. The cost of a ticket of an auditorium of maximum capacity of 400 seats is rupees 40 per seat. The auditorium gets filled when the cost of the ticket is rupees 40. So when the cost of ticket is rupees 40, 400 seats are sold. Thereafter, for every 1 rupee increase in the price of the ticket, the number of seats sold goes down by 8. 8 by 400 is about 2%, and 1 upon 40 is 25, 2.5%. And therefore, if we look at the product, the price increase will be more than the percentage decrease in number of seats sold, and therefore initially the overall revenue will increase until a point where 8 is less than 2.5% of or the percentage change becomes more for the number of seats than for the price that is there. So again, that will be difficult, but I think directly using the quadratic equation that we'll get. So basically, we know that revenue is equal to price per ticket into number of seats. Price per ticket is rupees 40, number of seats is 400. But as the price of ticket increases by a rupee, the number of seats falls by 8. So if the total increase is x rupees, the number of seats will fall by minus 8x, or they will fall by 8x. In this case, the revenue will be 40 plus x into 400 minus 8x. Taking the minus 8 common, we will get, this is x plus 40 as it is. From here, if we take the minus x common, we'll get minus 8 common, x minus 50. This becomes minus 8 into x square minus 10x minus 2000. Basically, I'm trying to minimize or complete the square so that we are able to find the minimum value at the point at which it happens. X square minus 2 into 5 into x minus 2000. Clearly, this becomes the second part of the perfect square. X square minus 2 into 5 into x plus 5 square. 25 minus 25 minus 2000 as it is. Adding and subtracting 25. So this becomes a perfect square now. So minus 8 into x minus 5 whole squared minus, in the outside we'll have 2025 remaining. This will become minus into 2025 will be 16. 16200 minus 8 into x minus 5 whole squared. Clearly, this term will be maximum when x minus 5 or the negative term is 0. So x minus 5 is 0. For any value of x which is not, where x minus 5 is not 0, x minus 5 square will be positive, multiplied by minus 8 will become negative, so it will decrease the revenue. And therefore, maximum revenue happens when x minus 5 is 0 or x is equal to 5. So the number of seats sold here will be 400 minus 8 into 5, which is 360 becomes the answer. Again, this is the standard format of the question. Such questions have been asked in CAT earlier as well. So if you've done the concepts, this should not be a very difficult question. Attempt time might go up to 2.5 minutes, but certainly something that can be looked at in the exam. One of the roots of the equation x square plus bx plus 2b is equal to 0, where b is real, is twice the other root. So if one of the roots is alpha, the other root is 2 alpha. Which of the following is the equation whose roots are b and b plus 1? So we can find the value of b and b, and from there work. So alpha plus 2 alpha will be equal to minus b sum of roots. 3 alpha is equal to minus b. I'm squaring this. 9 alpha square is equal to b square. Product of roots alpha into 2 alpha will be equal to 2b. 2 and 2 cancel. Alpha square is equal to b. Product of roots is 2b by a. Alpha square is b. So if we substitute this here, we'll get 9 b is equal to b square. So either b is 0, or we can cancel out b to get b as 9. If b is 0, then this does not make sense. 0 and 0 plus 1 will give us x into x plus 1, which again is not one of the options. Therefore, b is 9, which means roots of the equations are 9 and 10. If 9 and 10 are the equation roots, that means the equation will be x minus 9 into x minus 10, which will give us x minus x square minus 19x plus 90, which is option D as our answer. Again, a standard question in the sense that you would have done these earlier, just that 2 steps are involved, so that attempt time might go up a little bit, and therefore I'm saying moderate level of difficulty. When 2 is added to each of the 3 roots of the equation, this 3 roots of the equation, sum of roots 1 at a time, sum of roots 2 at a time, sum of roots 3 at a time, we get the roots as x cube plus 2p x square plus qx minus 18 is 0. A, B, C, P and Q are non-zero real numbers. What is the value of 4a plus 2b plus c? Now in this case, since we have a number here that is 18, we can say that the roots of these of this equation are alpha, beta and gamma. The roots of this equation will be alpha plus 2, beta plus 2 and gamma plus 2. This can be written as alpha plus 2. So here the sum of roots 1 at a time, 2 at a time, 3 at a time. The product of roots alpha plus 2 into beta plus 2 into gamma plus 2 will be minus plus minus. Minus of 18, minus of minus 18 upon 1, which is 18. If we open the brackets here, alpha beta plus 2 alpha plus 2 beta plus 4 into gamma plus 2 is equal to 18, which means alpha beta gamma plus 2 alpha gamma plus 2 beta gamma plus 4 gamma. So 1, 2, 3, 4, 1, 2, 3, 4 plus 2 alpha beta plus 4 alpha plus 4 alpha plus 4 beta plus 8 is equal to 18, which means alpha beta gamma, or we can write this 4 into alpha, 4 into alpha plus beta plus gamma, alpha beta gamma, these terms are used, plus 2 into alpha beta plus beta gamma plus alpha gamma 1, 2, 3 plus alpha beta gamma is equal to 18. Now this term alpha plus beta plus gamma is the sum of roots of the first equation. This will be of alpha plus beta plus gamma. From the first equation, we can say sum of roots 1 at a time will be minus of minus a by 1. Sum of roots 2 at a time, alpha beta plus beta gamma plus alpha gamma will be b upon 1. And sum of roots 3 at a time, alpha beta gamma will be minus of minus c upon 1. These are the values of ABC. So from here we can write 4a plus 2b plus c. We have minus 8 here as well, is equal to 80. This 8 goes on the right hand side, is equal to 18 minus 8, which is 10. Hence the answer for this question becomes option A. Again, I would call this moderate because it is very easy to get confused with so many variables. The trigger point here should be, since we have only one constant, we should start working with this constant and then rearrange terms. Easily 2 to 2.5 minutes to attempt the question. On the morning of Friendship Day, teacher took N friendship bands to her class, intending to distribute these bands among her students. She calculated that these would be exactly sufficient if every student of her class gave one band to every other student in the class. However, by noon, she observed that exactly two students had not turned up and exactly N minus 50 bands were used up. That means 50 bands were not used. Now, if the number of students in the class is X, what is the number of bands required? Each student will give a band to every other student. So each student will give a band to X minus 1 students. If there are 5 students, say 1, 2, 3, 4, 5, this person will give a band to 2, 3, 4, 5. This person will give a band to 1, 3, 4, 5. Again, each student is giving the other person a band. So between 1 and 2, 2 bands will be exchanged. 1 will give 1 to 2, 2 will give 1 to 1. 3 will give to 1, 2, 4, 5. 4 will give to 1, 3, 4, 1, 3, 5. 5 will give to 1, 2, 3, 4. So 20 bands are required because each person is giving away 4 bands. X number of students, each one giving X minus 1 bands. This should have been equal to the number of bands. Since 2 students did not show up, that means X minus 2 students were there. Each one gave away X minus 3 bands. In this case, the number of bands used was N minus 50. Subtracting the 2, we get X into X minus 1 minus X minus 2 into X minus 3. The number of bands unused. The number of bands that were supposed to be used minus the number of bands that was used will be equal to 50. So this becomes X square minus X. This becomes minus X square minus 5X plus 6 is equal to 50, which means X square minus X square plus 5X minus 6 is equal to 50. X square cancel. 5X minus X is 4X. 6 goes on the right hand side. 50 plus 6 is 56. X is equal to 14. So there were 14 students in class. If in the afternoon exactly one of these two students turned up, find the number of bands that remain unused. Now the number of bands that are there are 14 into 13, x into x minus 1. This is 13 square plus 13, which is 182. Now if there initially 14 students were there, out of which 2 did not come up, and then 1 turned up. So now the students are 13. So the number of bands required will be 13 into 12, each one giving 12 bands. 13 into 12 will be 156. So out of 182, 156 bands are used. So unused band will be 186 minus 182 minus 156, which will come out to 26. So the answer to question 10 becomes 26. I'd call it a moderate level of difficulty question because finding out the number of bands that are used is the challenge. Once that happens, the question will flow from there. Now, if you look at the overall level of difficulty, as said initially about moderate, 6 questions net correct will easily give you a 95 plus percentile, and attempt time to go through the questions would be around 25 minutes. Which are the 6 questions that I would look at? If I had to choose, I would probably choose 1, 3, 4, 5, 7, 9. Which are these ones? Definitely doing this one because this is a repeated format question. This question can be looked at or left for that matter. I am not counting it as one of the 6 easier questions because at least while writing it looks intimidating, writing the equation. So I'm leaving this. Would have done this for sure. Just putting the values 1 and 2 and solving. This also seems okay. Basically, writing the difference and then taking the square. This question again, I would say doable because we were essentially just trying to eliminate one of the values q. The only problem here was there were 2 solutions and therefore there was a chance of getting a little confused. This question I'm not counting because if we are not substituting ax plus b with y and working with the roots, then this question is not doable at that point. So I'm not counting this as an attempt. Would have done this because I've done similar questions earlier. This question also because there is some amount of you know substituting involved. I'm not counting this as a direct attempt. This I would have done for sure because again it looks intimidating, but the moment you realize the 18 is the point that you have to work with, we're just putting in formulas. This question, again, if we understand the concept of combination, or if we understand how to count the number of matches or the bands that will be exchanged, then this can be done. Otherwise, it might be a problem. So, not counting this as one of the easy questions. So, my attempt becomes 1, 3, 4, 5, 7, 9. Right? You might look at question number 8 and 7 and interchange them if you want, or 8 and 9, you can interchange 8 or 9 if you want. But for me, it will be 1, 3, 4, 5, 7, and 9.